So next up, we see that we have the CSAW 2018 Pwn Challenge Boy. We go ahead and run file on it. We see that it is a 64-bit ELF. Then we go ahead and run pwn checksec to check the binary mitigations on it. We see that it is a stack canary non-executable stack. We'll go into what those mean more in detail later on. And then we go ahead and run the challenge. We see that it prints out some output text, prompts us for input, and then after we give it some input, it provides us what looks like to be a timestamp. So now we go ahead and look at the binary engager so we can see what's going on. We go ahead and open it up and let it analyze. It will take a few seconds. And now we go ahead and look at the main function. We can see right here it is printing out that text that we saw when we first ran the binary, which we see that right here. Then we can see it is scanning an OX 18 bytes into the stack buffer right there. We're going to go ahead and rename it input. And then we can see that there's a comparison right here, comparing it against that value right there. The reason why it's listing that there is that is the signed value of that constant. We will go ahead and rename this right there. And we can see that depending on if it's true or not, either run command bin bash or run command bin date is ran. And looking at run command, we can go ahead and see that it's effectively a wrapper to system. So effectively, depending on the value, it is either system bin bash or system bin date is ran. And that's why we saw that time step there. We can see that the value is initialized to deadbeef. So in order to solve this challenge, we need to get this run command bin bash to execute. In order to do that, we need the compare val variable to be equal to this variable value at that particular point in time. And the question is, how can we do that when it is initialized to OX deadbeef and doesn't seem to change at any point in between? The answer is we look at our 1 point of input where it scans in OX 18 bytes of input into the stack variable input. Let's see exactly what we can write with that. So taking a look here, we can see that input is stored at the stack offset minus OX38. Thing is about stack writes, they'll start from an offset of like OX38 and then write towards the positive value. So it'll go from minus OX38 to minus OX30 to minus OX24. Let's see exactly how far into the stack we can write. OX38 minus OX18, so we can see that we can write to offset minus OX20 with this, which we see that compare val is a value that we can actually overwrite using this. What we have here is a stack overflow bug where we can write more data to a buffer than it can hold, so it can actually overwrite subsequent things. Let's actually see this in action. You see that our input is scanned in at this address right here. Let's go ahead and break at it in GDB. So we go ahead and run it. Let's take a look at the compare val value in memory right here, which was stored at offset minus OX24. So we go ahead and do that. We see that the value right there is deadbeef, which is what we'd expect it to be at this point in time. Now let's go ahead and overwrite it with just 4 ASCII ones. So let's first see what the offset is between the start of our input and compare val, which will be OX30 minus OX24. So go ahead and see that the offset is OX14 bytes. So we go ahead and just write a little payload to overwrite it with 4 ASCII ones. You have that there. And then when we go ahead and give it that payload, we see that we're able to actually overwrite it with 4 ASCII ones. And the thing is, we can just overwrite it with that value right there, and that should solve the challenge. Okay, next up, let's take a look at the exploit that I wrote for this. So we can see that it started off by importing pwn tools, and then we will run the target binary. I will attach GDB to it and break at the compare instruction that I'm trying to pass, with that being the address that we see right there. And the purpose of this is just to pause the exploit to make sure that GDB is able to break at that address before we send the payload. Below here, you will see the payload consisting of OX14 bytes to fill out the space between the start of our input and the value that we want to overwrite, followed by the value that we want to overwrite. Then we send the payload and drop to an interactive shell. We go ahead and run the exploit. We see in a second here that we were able to break on that compare instruction. We see it right there. We see that EAX is the value that we want it to be. So we then go ahead and step through it. And when we get to the run command call, we see that the argument to it is bin bash. I made a mistake here thinking that RSI was the first argument, but it's RDI. And we see that we're able to get the run command bin bash call. So with that, we should solve the challenge. We continue, and we see that we have a shell. And then we go ahead and comment out those GDB lines so we can run it without GDB, just to verify that everything is working. And with that, we see that we have solved the challenge.